In this video, let me consider one numerical on electrical circuit. In the circuit shown below, find current I. This is the given circuit. Here we supposed to find current I. So here we can see that current I is flowing through 3 ohm resistor. Let me find the current through 3 ohm resistor. So in this circuit, we can observe that 3 ohm and 6 ohm are in parallel. I will try to replace these two resistors by single resistor by taking equivalent value. So here I can say R is equal to 6 ohm is parallel with 3. I will try to find the equivalent value, that is when two resistors are in parallel, the equivalent value is product of those two divided by sum of those two, that is 18 divided by 9 is equal to 2. So I can replace 6 ohm and 3 ohm by 2 ohm resistor. So now I drawn the remaining circuit as it is. I will replace 6 ohm and 3 ohm by equivalent value, that is 2 ohm, that is connected between these two terminals, that is this is 2 ohm. Now here we can observe that this 2 ohm and 2 ohm are in series. So these two resistors are replaced by single resistor, that is 4 ohm, because 2 and 2 are in series, that is 2 plus 2 is equal to 4 ohm. Further we can observe that this 4 ohm resistor will come in parallel with 12 ohm resistor. So I can replace this 12 ohm and these two resistor by single resistor. I will call it as R equivalence equal to, here this 4 ohm will come in parallel with 12. So let me find the equivalent value, that is 4 into 12 divided by 4 plus 12, that is 48 divided by 16. Therefore R equivalence will be 3 ohm. So now I will replace 12 ohm, 2 ohm and 2 ohm by 3 ohm resistor, which is connected between these two terminals. Now let me redraw the circuit. So here the remaining part I will draw as it is. I will replace this 12, 2 and 2 by 3 ohm resistor. So here we are supposed to connect 3 ohm resistor. So this is 3 ohm. So now here we can observe that this 3 ohm and this 3 ohm are in series. That combination will again come in parallel with 6 ohm resistor. So I can write here 3 plus 3, these two are in series, that is 6 ohm. So this 6 ohm and this 6 ohm are in parallel. So let me replace that with again equivalent value, that is 6 is parallel with 6, that is 6 into 6 divided by 6 plus 6, we have 36 by 12 is equal to 3 ohm. Now let me redraw the circuit. I will replace 6 ohm, 3 ohm and 3 ohm by single resistor, that is 3 ohm. So let me redraw the circuit, that is 15 volt. I will keep it as it is. So here we have 1 ohm resistor. So here we have 3 ohm resistor. Let me show the current I here. So these three are replaced by single 3 ohm resistor, which is this one. So now we are supposed to find the current through this 3 ohm resistor. So now before finding that, I will try to find the total current in the circuit. So to find total current in the circuit, these two resistors are in parallel. That whole combination is in series with 1 ohm resistor. So here R is equal to 3 is parallel with 3. That whole combination is in series with this. So its value will be, that is 3 into 3 divided by 3 plus 1. So we have 9 by 6 plus 1, which is nothing but 3 by 2 plus 1. So here solving this, that is 3 by 2 is 1.5 plus 1. So we get total R is equal to 2.5 ohms. So now let me redraw the circuit. That is, we have 15 ohm resistor here, voltage source here, and we have total resistance of the circuit is 2.5 ohm, that is 2.5. I will connect here. This is 2.5 ohm. Now let me find total current drawn by the voltage source. I will represent it as X. X is the total current, that is X is equal to V by R, that is V by R. Here V is 15 volt, R is 2.5. So solving this will get X equal to 6 amps. So now here we can observe that X is the total current drawn by the voltage source. At this node, the current will divide. Part of the current will flow through 3 ohm resistor. Another current, I will call it as I2, will flow through this 3 ohm resistor. We are supposed to find I. So now I can apply current division rule. So current I is equal to, we have total current X into current through in another branch. That is resistor value in another branch, that is 3 divided by total resistance, that is 3 plus 3. 3 plus 3, which is equal to X value is 6. 6 into 3 divided by 3 plus 3 is 6, which is equal to 3 amp. So therefore current through 3 ohm resistor is 3 amp. Therefore current I is equal to 3 amps.